we'll start a new chapter, Thermodynamics. Reaction. As we know, reaction means change in state only. There are various types of reactions, physical and chemical. Physical reaction. Physical reactions mean change in physical state. For example, solid is converted to liquid, and that is fusion. It is endothermic reaction, therefore delta H fusion will be positive. Solid is converted to gas, it is known as sublimation. It is also endothermic reaction, we have to give energy, and delta H sublimation will be positive. Liquid can be converted to gas, which is called vaporization or evaporation. It is endothermic process, and delta H vaporization will be positive. Gas can be liquefied, and that is called liquefaction, and it is exothermic reaction, so delta H liquefaction will be negative. Liquid can be converted to solid. It is called solidification or freezing. It is exothermic process, and heat of solidification will be negative. Chemical reaction. Change in chemical state change takes place, or change in chemical composition. Now, how does chemical composition changes? For example, we take hydrogen, which react with chlorine and produce HCl. Here, hydrogen and chlorine are reactants. So, first of all, breaking of bonds takes place, and then formation of new chemical bonds give a new chemical, which is called change in chemical state or chemical reaction. If you want to break bonds, you need energy. So energy is absorbed during breaking of bonds, but when bonds are formed, exothermic reaction takes place, so energy released. The bond energy of hydrogen is 104 kilocalorie, chlorine 59 kilocalorie, and HCl is 103 kilocalorie. 2 moles of HCl form, so total 206 kilocalorie released. So here, we assume that energy of H2 and Cl2, which are elements, is 0. So they are here only, and energy of reactant is called ER. When we give energy to H2 and Cl2, breaking of bond takes place, and that requires 163 kilocalorie. So that now there will be no bonds between hydrogen and chlorine. So hydrogen move away from hydrogen, chlorine also move away from chlorine. Now there is no attraction or repulsion among them. It is neither reactant nor product. It is transition state, and this is known as activated complex. The energy of activated complex is known as threshold energy, and that is highest. So if you give 163 kilocalorie or more, system absorb only 163 and achieve this state, and that is called threshold energy. Now, if hydrogen collide with chlorine, then again attraction takes place, energy released, and energy released during this type of collision is 206 kilocalorie, because bond energy of HCl is 103, and therefore here we can say that energy released is greater than energy absorbed, and therefore overall at the end of reaction energy is released, and therefore this reaction is known as exothermic reaction. Or the other way, energy of product HCl in this graph is less than energy of reactant. So EP is less than ER. So when EP delta E, which we take EP minus ER, where EP is less than ER, then delta E will be negative. It is exothermic reaction. Nitrogen plus oxygen give nitric oxide. In this case, there is triple bond between nitrogen, double bond between oxygen, and 2.5 bonds between nitrogen and oxygen. breaking of nitrogen and oxygen require a lot of energy, and that is 226 plus 118 kilocalorie. Bond energy of nitric oxide is 141. Two bonds are formed, so total 282 kilocalorie. Nitrogen and oxygens are elements, so energy of these elements will be 0. But when energy is given, their energy increased, and now nitrogen is away from nitrogen, oxygen is away from oxygen, no attraction repulsion, activated complex is formed. But system absorbed 344 kilocalorie. If nitrogen collide with oxygen at this stage, then again energy released, but that is less because 282 kilocalorie released when bond is formed. So in this case we can see EP is greater than ER, or energy released is less than energy absorbed. So at the end energy absorbed, and that is why it is endothermic process. So when delta E, where EP minus ER, when EP is greater than ER, delta E will be positive, and it is endothermic reaction. Thermodynamics. The study of the flow of heat or any other form of energy into or out of a system as it undergoes a physical or chemical transformation is called thermodynamics. This is the name of the chapter, Thermodynamics. System. If we want to carry any reaction, we need a container like this, boiling of water in this container. So what is system? An extremely small part of the universe which is separated from the remaining part of the universe by a definite boundary, and on which we note the observation of the experiments carried out by external changes, is called system. So here, what is a system? A burner, a glass vessel, or a boiling water? The most important thing is, in a given scenario, the things which we observe, that is very important. We note the observation of the experiments. That is known as system. So here, what do we observe? Do we observe a vessel, or a boiling water, or a gas burner? I think we are interested in this only, boiling water. So boiling water is known as system, not this vessel. Remember that. Vessel is not a system. It is only a boundary which separates system from surrounding. So boiling water is a system. Surrounding. The remaining part of the universe, excluding system, is called surrounding. That means system plus boundary plus surrounding is equal to universe. Then why do we take universe in this case? Why can't we limit surrounding as a limited area around system? Because in some cases the whole universe can be a system. So therefore we need to take the whole universe, because whatever is changing occur within a given boundary, that will definitely affect the universe by small means or by large means. And that is why it is necessary to consider the whole universe. Now types of system. Open system. If you boil or heat anything in this container, and something can leave this container, like boiling water, then it vaporizes, and vapor will leave the container. That means exchange of matter takes place between system and surrounding. Plus, you can change temperature also by giving energy or by taking energy from the container. So this way, it is possible to exchange energy and matter with surrounding. Such system is known as open system. Second, closed system. Well, if you take this heater, then it is possible to boil water or boil anything in this container. But we cannot add while boiling this container, or we cannot remove that vapor from this container. So exchange of only energy with surrounding takes place, but matter cannot be exchanged with surrounding. Then it is called a closed system. Isolated system. A thermos flask. If you put hot water, it remain hot. If you put ice, it remain ice. That means you cannot add anything, you cannot remove anything, even you cannot boil it or heat it, you cannot remove heat from this. Such system, which cannot exchange energy and matter with surrounding, is known as isolated system. Well, it is not a permanent isolated system. Why? Because in isolated system, there should not be any exchange of energy. But you know that if you keep hot tea in this thermos for some times, it remains hot, but not after a long time. You cannot expect that the hot tea remain hot tea after 2 hours or maybe 2 days. It will be very chilled, cold, and that's why it is not a permanent isolated system. Well, there is one permanent isolated system, and that is universe, because total energy of universe, total mass of universe remains constant. Homogeneous system. This is the cup of coffee. It contains different ingredients, like it contains coffee, it contains water, it may contain sugar, but we cannot differentiate it. So there are different components, but one state, one solution. So it is called homogeneous system. Heterogeneous system. There is only one component, but different states. For example, a glass of water which contains few cubes of ice. Then it is called a heterogeneous system. Because ice is H2O, water is H2O, one component but different states, so it is called heterogeneous system. Basic properties of system. Pressure, which is in atmosphere, centimeter, millimeter or bar. Volume, which may be in liter or milliliter. Temperature in degrees Celsius or Kelvin. Moles 6.022 to 10 raised to 23. These are basic properties of any system. Classification of properties. Extensive properties. Some properties of substance depend on quantity of the matter, known as extensive properties. Extensive properties are expressed in the unit of per mole or mole inverse. Volume. Volume of 1 kilogram of water is equal to 1 liter. But if volume of 5 kilogram of water will be equals to 5 liter. And definitely these two are different. So, mass of substance, volume, enthalpy of formation, entropy, free energy, heat capacity, elevation in boiling point, depression in freezing point. These are known as extensive properties. Now, when we prepare any solution, the boiling point of solution cannot be 100 degrees Celsius. It is greater than 100 degrees Celsius. So it is known as elevation in boiling point. And if you freeze that solution, even freezing point cannot be 0 degrees Celsius. It will be less than 0 degrees Celsius. So it is known as depression in freezing point. And these are colligative properties. Means properties depend on number of particles, number of solute particles. So they depend on mass, and therefore these are known as extensive properties. if you double the scale of any one of this, the property will be double. That is the criteria to find out whether it is extensive or not. Next, intensive property. The properties of the substance which do not depend upon the mass of the substance but depend upon the structure of the compounds are known as intensive properties. For example, boiling point. Boiling point is not an extensive property. Yes, elevation in boiling point is a different case. But boiling point is not an extensive, it is intensive. Whether you take boiling point in a large container or a small container, the boiling point of water remain 100 degrees Celsius only. So boiling point is intensive property. Examples of intensive property: boiling point, freezing point, melting point, density, surface tensor, viscosity, refractive index, dielectric constant. This is the formula of force, where epsilon 0 is dielectric constant, and the dielectric constant is defined as the ratio of the permittivity of a substance to the permittivity of free states. Temperature, specific heat, chemical potential, pressure, concentration, heat. These are intensive properties. When any extensive property is divided by mole, then it becomes intensive property. For example, volume is an extensive property. But if you divide it by mole, then it becomes molar volume, V bar. Then it is volume per mole and it is intensive property. Enthalpy is extensive, but molar enthalpy is intensive property. Molar entropy, etc. State of a system. A thermodynamic system is said to be in a certain state when all its properties are fixed. Fundamental properties are pressure, temperature, volume and composition. If any of these properties is changed, the system also observes changes. Therefore, these are known as state functions, state variables or thermodynamic parameters. So pressure, temperature, volume, compositions are known as state functions because they depend on the state of the system. If you change state, then there may be change in these properties. A system is expressed along with state function. For example, argon. Argon is in gaseous state. Its pressure is mentioned, its temperature is mentioned. Then, pressure and temperature is required to express the above system. So they are known as independent state variables. And from pressure and temperature, we can find out volume also by using PV is equal to nRT equation, and that is why volume is dependent state variable which depends on pressure and temperature. Potential energy. What is potential energy? In physics, you refer U is equal to mgh. M is mass, G is gravitational force, and h is height. So when any substance is at certain height, we can observe its potential energy from ground state. For example, these two are the same type of pen. Assume the weight of these two is equal. Now one is kept over here, another is on top. Both are having different height from ground level, therefore their potential energy is different. But if you bring them on the same level so that height becomes same with reference to ground, then their potential energy will be same. Doesn't matter how these two pens reach to this level, but once they reach over here, their potential energy will be same. That means the potential energy is a state function which depends on mass and height. It does not matter how you bring that particular object to that height, and that is why route or path is not important to measure potential energy. So the value of properties of the system which depend on the state of the system but do not depend on the method how the state can be obtained is called state function. So state functions are path independent. They do not depend on the path, and the examples are internal energy, enthalpy, entropy, free energy, pressure, temperature and volume. Not state functions, matlab they are path dependent functions like heat, work, heat capacity. So these depend on path. Thermodynamic equilibrium state. When you take cylinder, a gas is filled in the cylinder. On top of it, there is a piston, which is frictionless piston. That means easily moved up and down. It is stationary state. Suppose piston is not moving up or down. It remains stationary over here. That means pressure, volume and temperature must be constant. So when all these properties are constant, piston does not move here and there. Such state is known as thermodynamic equilibrium state, where all these properties are constant. Thermodynamics non-equilibrium state. Suppose a gas is filled in it and suddenly you find change in the position of pistons, which is frictionless. Again, there is a hot gas, there is a cold gas, there will be different pressure and temperature over here, different pressure temperature at this level. That means every time pressure, temperature, volume changes due to motion of piston. That is known as non-equilibrium state. And here piston is not stationary, it is continuously moving. Process. Well, there is one more word which we have already discussed, reaction. And reaction means change in state. Process, it is also change in state. Then what is the difference between reaction and process? Definition wise it looks same, but there is very small difference between reaction and process. When you observe change in state of only system, then it becomes reaction. You are observing change only in the system, then it is called reaction. But when you consider change in state of system as well as surrounding, then it becomes process. So in process, it is necessary to consider surrounding also, that while doing some certain changes in system, what happened to the surrounding also. That is very important. So then it is called process. First, isothermal process. Isothermal process is defined as one in which the temperature of the system remains constant during each change in the state of the system. That means delta T will be 0. So there is no change in the temperature. That is known as isothermal process. For example, closed system. If you take a closed system where matter cannot be exchanged, but you can exchange energy, and suppose inside this container, if exothermic reaction takes place and we have to maintain temperature, then this extra heat which release came out. So during exothermic reaction, the heat evolved is given to the surrounding to maintain the temperature, then it is called isothermal process. That means during isothermal process, to maintain the temperature of the system and surrounding, we have to exchange energy. Otherwise, temperature changes. But to maintain temperature, it is necessary to exchange energy. Like in exothermic process, it is necessary to bring heat out of the system so that temperature of the system remains same. And in opposite direction, endothermic process. In endothermic process, energy is required. So it has to absorb from surrounding to maintain temperature. So during endothermic reaction, the heat absorbed from the surrounding to maintain temperature, so that exchange of energy takes place and temperature remain constant. Adiabatic process. During the change in the system, if the system does not lose heat or does not receive heat, then the process is called adiabatic process. That means isolated system, where energy inside the thermos remain constant. But if in thermos flask exothermic reaction takes place, then heat will remain inside the thermos, it cannot come out. So that heat will increase temperature. So temperature of the system increases during exothermic reaction of adiabatic process. Endothermic reaction. When endothermic reaction takes place, heat cannot be absorbed from the surrounding, therefore it will utilize its own heat, and so the temperature of the system decreases. So there is always change in temperature during adiabatic process, and there is always change in energy in isothermal process. So these two processes are opposite. Next, isobaric process. If the system contains gaseous material and the pressure of the system remains constant during the change, then the process is called isobaric process. In this case, dP will be 0. Suppose P external is constant. For example, in this case, we have filled hydrogen gas and oxygen gas, but we keep the pressure on this system constant. Now when H2 and O2 is converted to H2O, number of moles of reactants are 3 and number of moles of product is 2. That means number of moles decreased. So volume also decreases. We are not changing pressure, but due to change in number of moles, volume changes, and therefore piston moves downward automatically without applying pressure. So in isobaric process, we keep pressure constant, but that will affect volume. If number of moles of reactant and products are different, then at constant pressure in forward reaction, number of moles decreases. So we can say that volume decreases and piston moves downward. Now N2O4, which can be converted to NO2. So here number of moles of this reaction, number of moles of reactant is 1, number of moles of product 2. Therefore, when forward reaction takes place, number of moles increase. So volume also increase. Here we are not changing pressure. We keep the same pressure, but because of number of moles of product are more than number of moles of reactant, as reaction proceed in forward direction, it require more volume, therefore piston move upward. So at constant pressure, in forward reaction, number of moles increases and volume increases, piston move upwards. Reversible process. Well, you know reversible reaction. Reversible reaction means reaction occur in both this direction, forward as well as reverse. That is called reversible reaction. But reversible process is slightly different from reversible reaction. Here, reversible process means a thermodynamic reversible process is one that takes place infinitesimally slowly, and its direction at any point can be reversed by an infinitesimal change in the state of the system, is known as reversible process. Reversible expansion of gas. That will, first condition, that whatever change we carry on this system, it should be very small, so that we can bring it to original state. Suppose this is initial state, where we are keeping pebbles on the surface of the piston to produce pressure. Pressure say P1, a volume of gas is V1. This is initial state. Now, if we remove only one small pebble, which is having hardly some mass, but then there will be slight change in the pressure. See, one pebble is removed, so piston moves slightly upward because pressure is changed, it is decreased. So now net pressure will be P1 minus dP, and that is slight change in the volume also, but this is very, very small. Now, if you put pebble on top, then again it will you can bring it to the original state. That means this is reversible. So if you add one pebble, you will get the original state. Only one pebble. So this is a very small change, and that is why it is possible to bring it to original state. So this way, if you slowly remove one by one pebble, then there will be small changes every time, but every two adjacent changes are in equilibrium. The change in volume is dV. So if you carry such small changes for a long time, finally we get this state, and the pressure remains P2, which is different from P1, and volume of gas also V2, which is different from V1. So this way, this becomes reversible expansion of gas. Why? Because we have changed pressure very slowly, and finally we achieve this state. And between every two adjacent states, there is always equilibrium. So in this process, the equilibrium is established between system and surrounding at each microscopic level. Irreversible process. When a process goes from the initial state to the final state in a single step and cannot be carried in the reverse order, it is said to be an irreversible process. For example, irreversible expansion of gas. This is initial state. Pebbles are kept over here, which produce pressure P1, volume is V1, temperature T. Now, if we remove all pebbles suddenly, except 2 or 3, then there will be sudden change in the pressure, and it will the piston move upward suddenly. But in that case, gas which is inside this cannot experience this sudden change easily, and therefore at some places there will be different products of pressure volume, and you can see here it may be P2V1, P2V2, P1V2, P1V1, P1V1. It is everywhere the pressure volume products are different, and that is why the final state which suddenly appear cannot be brought to the original state immediately by putting all pebbles again. So this is irreversible. You cannot bring it to original state. There is no equilibrium between initial state and final state. That is irreversible expansion of gas. Equilibrium state. Let us take example, hydrogen gas, 3 moles hydrogen gas, 5 bar pressure, 100 degrees Celsius, initial state. Expansion takes place and it is converted to 1 bar. So see, pressure decreases, therefore it is expansion, temperature decreases, final state. So forward is expansion, reverse is compression. It is a closed system. Now we plot pressure versus temperature of this reaction. Initial state is this, A, where the temperature is 100 degrees Celsius, pressure is 5 bar. So we are here. We can go to the final state here by two different processes. Either we go straight away from A towards pressure, that will remain, in that case pressure remain constant but temperature changes. If pressure remains constant and temperature changes, this path is known as isobaric. So, step 1 is isobaric process. Now we reach to this point B, where pressure is 5 and temperature is 50. That means in the beginning we have decreased temperature, so it is cooling. Then we bring pressure down to 1, and when pressure brought to 1, there will be same temperature, so it is isothermal. So second step is isothermal, first step is isobaric, or vice versa. Isothermal first and then isobaric second. So finally we reach to C, which is final state. Path 1, by lowering temperature at constant pressure, we can reach from A to B. By lowering pressure at constant temperature, we can reach from B to C. Next, if initial state is A and final state C, which can brought by changing pressure and temperature slowly, then it is called reversible. So path 3, by lowering temperature and pressure slowly, we can reach from A to C final state, that is reversible process. So if you plot pressure versus volume, then this is isobaric, this one is isochoric, isothermal and adiabatic.